Okay, so let us start. Good evening, everyone. Welcome to today's set colloquium at TIFR. For those of you who do not know what ASSET is and what it stands for, ASSET stands for Advances in Science, Engineering and Technology. Essentially, this forum conducts colloquia which complements the Natural Sciences Faculty and Mathematics colloquia every week. The colloquia are usually held at 4 o'clock on Fridays, and it covers topics essentially on the instrumentation, experimental sciences, computer science, electronics, medicine, and so on. Of course, we also organize the colloquia on topics which are of general interest to the audience, like the one that we have today. We are very fortunate to have today Professor Rajani and Professor Viraj Kumar, who are going to speak on a very, very interesting topic, which is titled as 5 Degrees of Variation at Nalanda, a Stellar Hypothesis. I'll just take a minute to introduce both the speakers today. Professor Rajani is an associate professor at the National Institute of Advanced Science Studies, NIAS, from Bengaluru. Her research interests are in the landscape archaeology and geospatial analysis for cultural heritage. Her recent publication includes the upcoming book, which is titled Patterns in Past Settlements, Geospatial Analysis of Imprints of Cultural Heritage on Landscapes, which is slated to, I think, be released in 2021 next year. She is an elected member of Indian National Young Academy of Sciences. This is IISc for 2018 to 22, young affiliate 2019-23 of the the World Academy of Sciences, which is TWAS, and recipient of PR Pisharoti Memorial Award 2019, which is given by Indian Society of Remote Sensing, that is ISRS. Professor Viraj Kumar is a visiting professor at the Divecha Center for Climate Change at the IISc, Bengaluru. He contributes to the center's educational outreach and policy initiatives, and his research interests lie in the use of technology to improve teaching learning processes. He was a consultant to the committee to draft the National Education Policy during 2017 and 18, and he is a member of ACM India Council. So with these few words to introduce today's speakers, so now it is over to Professor Rajani, and I understand that they will be seamlessly taking roles and complete this colloquium. Thank you very much. It's all over to you both.
Thank you. Thank you very much. Thank you, Professor Dr. Satyanarayana, for that introduction and also for this opportunity. Yes, of course, we miss. I hope I'm audible.
Yeah.
Yeah, we miss the opportunity to presenting. Presenting this colloquium in person on campus, but we are really happy to present to this audience. This particular work first started when I was doing landscape analysis of Nalanda, and where I was actually looking at the environs of Nalanda outside the protected area to see whether there are telltale signs of other buried archaeological features. And then something led to look at inside of the excavated buildings, 3 of which you can see in this title slide. And you can also see they're all slightly off tilted from each other. And that is the theme of this topic, 5 degrees of variation in their tilt. Nalanda itself, as you may know, is known to be the oldest residential university, in fact, monastery, and was known to be active from about 4th, 5th century AD till about 12th century AD. So all these structures within Nalanda were built at different times in that span. Nalanda was forgotten after 12th or early 13th century. And some historians, especially Tibetans, wrote about it, but much later in the 20th century, in the 19th century, some of Chinese and Tibetan records got translated to English, which later the British explorers used those translations to come and find where this important location was. And this was the location which attracted monks from very far off places, the famous one being Xuanzang, who mentioned the site and its structures, and also the philosophy and what happened here and so on. So there are, of course, archaeological excavations that has happened here, starting from 1861. Some of the early excavations, I mean, you can imagine finding a site large as Nalanda, some of the early excavations were not well documented, and a lot of renovation has happened to these structures, which also complicates the matter of dating these structures. Archaeological excavations themselves haven't been able to provide unquestionable dating of these structures yet. And we, in the manner of identifying these structures orientation, have an alternate way of dating the structure. So with this introduction to the site, I will start my talk. Yeah. So this is a top-down view of the whole site, protected area of Nalanda on the left side. The areas marked in yellow, and the sacred structures, which are called as temples, are marked in red. Outlines are marked in red. And the dwelling structures, which are the monasteries, are marked in blue. For this particular study, we are not really concerned about the dwelling structures. We don't think dwelling structures were really oriented with any special method. It was the sacred structures that were oriented. And by orientation, I mean on the right, you have a dial. It is the azimuth, that is the angle from the true north. So when we analyze this site and specifically the sacred structures, we found all of them had a tilt, and this tilt ranged between 94 to about 99 degrees. Variation, as the title of our talk comes. So we found that all these structures had certain specific angle to which they were facing, and they all were not exactly same, and they were very slightly different from each other, and the difference ranged for 5 degrees, except for this one structure called Temple 3, T3, which we were able to measure at least 3 angles, partly because the site was renovated or rebuilt on top of an old construction multiple times. So I talk about each of these structures for a little bit. T3, which produced at least 3 orientation angles. As you can see in the ground photo here, you can see steps of at least 3 phases of its construction. In fact, archaeologists who excavated this place have found that there were 7 phases of this temple's construction. Now, when we measured the angle, which our method we will come back to later, we had to find at least 2 east-west lines, and then we took the average of that. This particular structure, we were not able to get 2 of any one phase. So we actually exclude the structure, but still it's a very important structure. One scholar, he has likened this particular structure's way it is built to Russian dolls, as though there were smaller structures inside bigger structure. Here are some photos of different stages of excavation of this particular structure. On the right-hand lower side, you see how it looks today if you visit the site. On left-hand top side, you will see how it looked when Cunningham first visited the site. So you can imagine if a structure is in this condition now, we wouldn't be able to measure its orientation. And you can also see how different stages of its conservation. Also here to record, as part of the conservation, bricks of the size of Gupta and Pala period were reproduced and used for renovation of the site. So now, apart from the complications of regulatory hurdles today, if we want to date a brick, there are means of dating brick using scientific methods now. But if we wanted to date the brick used in these structures, we would have the problem of identifying an authentic old brick, because lots of new bricks have been made in the last 150 years to renovate the structures to make it presentable as it looks on the site today. The next structure is Temple 12. These numbers are given on the basis of sequence, in the sequence that they were excavated. That's why they are not in sequence, because number 2 and number 1 belongs to one of the monasteries. Number 1 and 4, 5, 6 belongs to the monasteries. That's why Temple 12 was the number 12th object to be excavated. So Temple 12, here is a picture of it. On the right, this has a very neat square platform, and we were able to measure 2 or more lines and take an average of that. And there is Temple 13, which looks like this from its east view, and Temple 14, again facing the east. Temple 2, of which we only have the lower portions of the structure that's left. And a Sarai temple, which also is a square base structure. So these are the sacred structures. By sacred, I mean they housed images of Buddha, and these were used for worship, and whereas the monastic structures were used for monks to live in. So we were quite sure that some means of orienting these were used, because they're all facing east. So we started looking at why are they not exactly east and about 4 or more degrees south of east. So were they really aiming at east and they went wrong, or were they aiming at something else? So to look at that, we reviewed what were the orientation methods that were in use at the time Nalanda was active. Yes.
Professor Rajani, will you be able to take a question or two during your talk?
Sure, I'll be happy to.
Okay, there's one, I'm sorry, I can't pronounce the name,
yeah.
But it starts with JSZ. Can you please ask your question? JSSZ, unfortunately, it's not a renamed, I think. Okay, fine, maybe we'll get back. Now the hand has come down, so.
Okay.
Please go ahead. Yeah.
Okay. So we reviewed what were the methods of orientation that were in practice during Nalanda and before. So we found that Vedic processes of selecting and preparing a site for Indian temples included laying out an elaborate altar and performing rituals that went for a long period, several days. So here is one such Vedic altar, and the first, as you see, there is a lot of things happening in this elaborate layout, but the first thing to do was to establish the east-west line, and then the rest of the altar was drawn. So establishing an east-west line was the first step to start the ritual towards building temples. Varahamihira, a renowned astronomer and mathematician who lived in the 6th century, described traditional norms of temple construction in his work Brihat Samhita, stating that the temples should face exact cardinal point and not any intermediate points. And more recent work by Yano notes that determining cardinal direction was one of the prerequisites for constructing temples in ancient India, and suggests there were two divides the methods for identifying east-west line into, there were two methods. One is by observing fixed stars, and the second one was observing gnomon shadows. We feel Nalanda temples were also oriented to something, and now we look at what that something was. And by slowly, as I will describe, by elimination, we arrive at our hypothesis. First one, we consider whether they were aligned to cardinal directions, aligned to, I mean, they aim cardinal direction, but went wrong by a few degrees. But we find that Nalanda, which was active between 4th and 12th century, and there was a method which later by Alberuni was named as Indian circle method. But this method has been recorded in Katyayana Shulva Shastra, which could achieve an east-west line for maximum error of 0.5 degree. But all our temples have a error of more than 4 degrees. So we don't think they were, because if they were aiming at cardinal direction, they had a better method that was already prevalent. So we don't think they were aiming at cardinal direction, they were aiming at something else. So here is a drawing how they achieved this east-west line, which had a error up to 5 degree, where they had planted a stake, a gnomon, and drew radius of the same length of the gnomon, and observed the tip of the gnomon shadow enter and exit across the midday, and then join these 2 points, which made the east-west line. And this east-west line would be more accurate if they were drawn closer to the solstice, and it had up to 5 degrees of up to 0.5 degree of error if this observation was made closer to equinox, when the sun's declination changes very fast. Here is another drawing showing the same thing, how east-west line was, that is E1 and W1 was achieved by doing this measurement. So when they had a method that was more accurate to identify east-west, they definitely wouldn't have gone, I mean, that was prevalent for centuries before Nalanda was active. They definitely wouldn't have been aiming at cardinal direction and then gone wrong by more than 4 degrees. So therefore, we think they were looking at something else. Again, here is some further references that Brahmagupta was the first one to identify this 0.5 degree error, and Shripati was first one to suggest the correction for this 0.5 degree error. So this just shows the sort of temperament at the time for accuracy. So we don't believe at all that Nalanda people could have gone, the constructors of these temples could have gone so wrong, and therefore they were aiming at something else. So now we consider what could they be aiming at, whether they were aiming at sun, that is rise of sun. So there is work on temples of Southeast Asia where it is suggested that a gnomon shadow was used to align or draw the baseline for temple construction. And this way, sunrise on a particular day was used. So there are many temples in this region, which ranges all across the solar declination across the year. So, but these temples were built only few decades apart. So this is quite believable for this set of temples. Whereas the range at Nalanda is very narrow. We only have a difference of 5 degree, not 23.5 north and south kind of range. So here is a dial. Again, I show how the 5 temples at Nalanda and how their orientation is marked. Then we all considered whether it is any day in solar calendar. The major days are solstices and equinox. These orientation don't fit, but you could wonder whether it was some auspicious day, not either solstice or equinox. But there is no, if such a day had to be practiced across several centuries, they should have had a calendar that is strong enough. We don't have any evidence for that. And plus, even if it was such a day, it would, of course, dependent on a particular auspicious day's weather of being cloudy or so on, which also makes it very, sort of doubtful that they could have used sun's angle on a particular day, because also sun's angle changes rapidly. And if it was cloudy, and the angle on the next day would have been very different. So we don't, therefore we eliminate sun. We then consider moon. Moon has complex faces, and it is hard to get one point target, and there is no shadow other than very rare full moon days. And the major azimuth angles for lunar calendar is the lunar standstills, major and minor standstills, which is the northernmost and southernmost rising points or setting points, in this case rising points of the moon, which we have here marked. Again, all these measurements are made for Nalanda's latitude and longitude. So this will of course differ from place to place. Then we consider whether a star was the target for orienting Nalanda structures. Star has been used by other ancient cultures. So there is a suggestion that the pyramids were aligned to cardinal direction using circumpolar stars. And also these two temples in Greece, Ramnos, Greece, are believed to have been oriented to rising of a star. Again, you can see there is a slight tilt between the two orientations of the two, and this is also believed, and these were built about 200 years apart, and the hypothesis is that they were oriented to the same star. So if we consider star as a target, then that would explain this 5 degrees of variation because of the Earth's axial precession. So the Earth's axial precession, I don't have to explain to an audience from TIFR, but the axis of Earth today, the northern side points to the polar star, close to polar star, and it sort of precesses over 25,000 odd years a whole circle, and it is rather like the top spinning of a top. So now I consider what was the kind of temperament about astronomy at Nalanda and the region. Aryabhatta I, who lived in the 5th, 6th century, is known to have practiced astronomy in Kusumapura, which is identified with, which is Kusumapura or Pataliputra, which is identified with today's Patna, which Pataliputra was the capital of Gupta Empire, and it is just 60 kilometers north of Nalanda. And there is enough evidence of interactions between this area. In fact, there is also a claim that Aryabhatta headed the institution or the observatory at Nalanda, because he's called in some sources, he's called as Kulapati. Now, coming to how the rising of a particular star, seen as soon as it has risen on the horizon, changes over the whole precession period. Here I have used stellarium. I mean, I've used stellarium for all kind of visualization. Without stellarium, this work wouldn't have been possible. So I'm showing the view of eastern horizon at Nalanda at minus 1000 BC. And I'm marking one star, Spica, which is the Sanskrit name is Chittara. And I'm marking also the ecliptic and the equator. And here is some metadata. I specifically want to draw your attention to the azimuth here in minus 1000 BC. It is about 85 degrees and 23 minutes and 10 seconds. Now, when I come to 0, that is start of the AD, this Spica star has moved beyond east, and its azimuth is 91 degrees. So I will just animate across thousands, a slide for every 1000 years. For instance, here is 1000 AD, 2000 AD, which is now around, and 3000, 4000, and so on. So this is how a star would move across the horizon over the whole cycle, whole precession cycle. So coming back to 25,000 years. Now, for us to check whether these Nalanda structures were really aligned to this particular star, if we had a strong date for any of this structure, then we could have correlated that. But unfortunately, in the available evidence through archaeology, we don't have very definite dates for any of these temples. We have some relative dates that something was built before, something was built after, and so on. But we don't have strong dates for any of these structures. Only what we know is Nalanda was active between 4th, 5th century to 12th century. So we believe that these all were built between that time. So we started looking beyond Nalanda to see whether there are other sites whose sacred structure have similar orientation and for whom we may have some good dates. Sacred structures from sites that where there is evidence of interactions with Nalanda, which is important, so that these ideas had to have crossed to these sites. Structures whose construction is sufficiently exposed. So of course, for instance, there is a site, Odantapuri, which was contemporary of later part of Nalanda, but we don't know where the site is. So we obviously can't measure such site, though we have some idea of the date of that site, but we don't know where the site is. So we can't measure that site. So we need sites whose structure is exposed and whose structure is not round. There are lots of stupas that are round. So we need structures that has east-west line. Structures whose central construction are symmetrically stratified. In the sense, we have to be able to identify two east-west line whose average we can take. We will speak about our method in a minute. Structures whose orientation deviate from cardinal direction in the manner similar to temples at Nalanda. So we found a few. Here is Vikramshila on the top and Somapura down. Vikramshila is a site in eastern Bihar in Bhagalpur district. Somapura is in today's Bangladesh. Both these were built by the same king, Dharmapala, who's the second king of Pala dynasty. The Pala dynasty overlapped with the later part of Nalanda, which is 8th century to 12th century. So this is a view, top-down satellite view of Vikramshila and Somapura. The central structures are the sacred structure. Monasteries are in the surrounding quadrangle. So here are some ground images of Vikramshila, which I was able to visit. The other site we found had similar orientation. Was Bodh Gaya, the central structure of Bodh Gaya. Bodh Gaya is also a very famous Buddhist site because this is the site where Buddha attained his enlightenment. However, the central structure doesn't date from Buddha's time. It dates more like 4th or 5th century AD. Samye is in Tibet, and Samye is supposed to be the first Tibetan monastery, and it was built quite early in Pala period, and it was built based on the first Pala period monastery architecture. So that also has a similar orientation. So we use this site as well. So with this, we have increased our data points, and we find among these structures, we have strong dates for 3 of them. Bodh Gaya also, we don't have very strong dates of when exactly it was built. Whereas with Vikramshila, Somapura, because Vikramshila and Somapura is connected to the life of Dharmapala, and Samye, for which we also have some evidence of when it was built. Now, I again go back to Stellarium, and then I put it for 400 AD, which I think is the earliest part of this span of construction. And how do I play this?
Is this the video slide?
Yeah.
Sure.
It's playing. So, and I keep it, I run this from 400 January to December to see which all stars rise in 400 AD at around 94 degree, which is around our least of the 5 degree variation. We found 4 stars rise at this point. The point I'm marking with my this one. Then 1 star from the constellation of Hydra. Here, this one. And 1 star, Spica being the 3rd star, this one. which was very close to the intersection of ecliptic and equator at that time, and this one, Beta Librae. So these 4 stars was rising around 94, plus or minus few fraction of a degree in 400 AD. So here are their azimuths in 400 AD and 1200 AD. As you can see, only Spica and Beta Librae has the range that we are looking at, the 5-degree range. Here is another visualization of Spica at 400 AD, and it moves about 2 degrees by 800 AD, and another little more than 2 degrees on 1200 AD. The same kind of visualization for Beta Librae, which at 400 AD, at 800, and at 1200. So the Beta Librae is not moving as much as Spica. Spica moves about 5 degrees and Beta Librae moves slightly less than that. Now we consider these 2 stars, whether they could have been possible targets, pros and cons for those. Beta Librae belongs to the asterism or the lunar mansion called Vishaka Nakshatra, and Vishaka Nakshatra happens to be Buddha's birth star. Whereas Spica is a brighter star, and it held a very important position, astronomical position, being very close to ecliptic and equator in the early centuries of AD. For instance, you see here, Spica was here in 400 AD, which is very close to ecliptic and equator. It sort of played a role what pole star is now playing, marking the north of a celestial globe. This was marking one of the sites. Whereas Beta Librae was not really particularly astronomically important. It also is much dimmer star.
Can I ask a question just now?
Yeah.
You see, you said Spica was very close to the intersection of ecliptic and equator.
Yeah.
The question is how close? What is the angle?
Yeah, I will come to those. I'm just listing what is the importance of Spica here. Spica is the 16th brightest star in the night sky with an apparent magnitude of 0.95, which extincted to 3 degrees. I'll come to the importance of 3 degrees in a few minutes. In fact, my colleague will speak about that. It is the brightest star in the constellation of Virgo. It lies about 2 degrees from the ecliptic. The declination was 1 degree north in 210 BCE and 1 degree south in 145 CE. And it crossed the equator about 31 BCE, all from stellarium, of course. And it was the closest bright star to one of the 2 intersections, which I've already spoken about, being the closest in the year 346. Offhand, I mean, I can give you the measurement after I close this PPT, but the closest is sort of how close it is. I don't have it offhand, but you can see the other measurements what I have here. Located at such an astronomically prime spot, it is not surprising. It attracted attention of astronomers from many civilizations. In Indian astronomy, Spica is one of the 27 zodiacal asterisms. It is called Chitra Nakshatra. Aryabhatta notes that 2 halves of the ecliptic were divided on one side, close to where Chitra Nakshatra is located. Chitra belongs to both Kanya and Tula zodiacal astronoms. While comparing the longitude of Spica and other bright stars with data recorded earlier by Timocharis, it was Hipparchus who discovered that the Spica had moved 2 degrees relative to the autumnal equinox. Here is a visualization I've tried to pull out from these dates. This is how Timocharis would have seen, or rather recorded, and this is the difference that Hipparchus would have seen, and therefore Hipparchus is credited with the discovery of one of the effects of precession. The idea of precession, how it got transmitted. Of course, there are evidences of the idea of precession much earlier in the Western literature than in Indian literature. There are evidences indicating that texts of Greco-Babylonian astronomies were transmitted to Western India, which was known, it was a place that hosted many Greek expatriates, and there are other evidences of astronomical sort of tables and notions also being transmitted to this area. The idea of precession, again, I'm quoting from Pingree, was transmitted to India along with other astronomical theories between the 2nd and 5th century AD. Varaha Mihira, who lived in Ujjain, part of Gupta Empire, which Ujjain was, of course, part of this Kshatrapas, where all these ideas had been, belongs to the area where these ideas had been transmitted to, was part of Gupta Empire later. And he observed the shift in the commencement of sun's northern and southern course when compared to what was recorded earlier by the earlier astronomer Lagada. Sorry? Yeah. Now I will request my collaborator, Viraj, to take over and speak from here.
Thanks, Rajani. So, so what we've just been talking about is, that awareness of the idea of precession. Now, when it comes to actually trying to orient these structures to particular stars, unfortunately, we don't have any evidence of the exact method that they used. But what's shown here pictorially is a fairly low-tech method for doing this kind of orientation, where they would have some sort of a stick and they would observe the star above that and use a plumb line at the close end and mark that point. And so if we could join those 2 points, and that would point to the direction that the star was rising. Now, as we have observed, that as the star rises, it sort of moves further and further away from east. And that's going to be important later on, because if you imagine doing this measurement, over a unoccluded horizon, then you will get a certain measurement. But if there was an occlusion in the direction of the star rise, you would have to wait for the star to rise beyond that occlusion. And since as it is rising, it is moving further away from east, the orientation that you would get towards that star would be further away from east, the greater the occlusion. So this point is something that we will come back to when we actually look at the data that we have. So this is merely a guess of one possible way in which they could have oriented, but we wanted to just make this point about the occlusion very clearly. Okay, so now let's look at the actual methodology that we used to get our data. So we found images that were, as close to the vertical as possible to minimize parallax, of course. And we looked for these long east-west walls which we could measure. And as Rajani was saying, we tried to find 2 parallel lines and just take the average of those. So wherever possible, we tried to find such walls, one to the north and one to the south of the central structure, which is what we assume was oriented with the greatest care. And so we tried to find these straddling lines and just take the average of those. So when we are talking about the angle for a particular site, that is what we're talking about, the average of these 2. So here, what we're showing is across the whole 26,000 year cycle that was measured for the 4 stars that Rajani was mentioning, what is their angle. So the vertical axis, the y-axis, is this azimuth at 3 degrees altitude. This is an assumption we have made that this was the height at which the observation was made. And then on the y-axis, on the x-axis is the year, right? So the year spanning from -1,000 to 25,000. So the period of interest for us is a narrow range, which we will come to in a second. But the first thing to observe here is that z is a function of y. Right, the azimuth is a function of the year, which depends on the star itself, the latitude of the observer, and the star's altitude when it was observed, which, as I said, we are fixing as at 3 degrees for this data that we're presenting here. So here is our insight that, and this is where we potentially have a method for dating these temples. So if the temple with orientation Z was constructed by aligning with a particular star, then we can estimate the year from the angle, right? So since we know what the angle is, we can estimate the year if we can just simply invert this function. And we're very fortunate that in the period of interest for us, if we zoom into this period, I mean, these are very simple functions. They're basically linear functions at this point. I mean, we can get a very good approximation to them with just a simple linear model. So inversion is quite straightforward. Right? As Rajani mentioned, 2 of these stars actually don't fit our date range. It's only Spica and Beta Librae. So if we further zoom in on those, we see that there's actually very little difference between these 2. And with the kind of data that we have, we are actually unable to distinguish between these 2 stars in the sense that both of them could work with our hypothesis. So at this point, we don't know between these 2 stars which of them could have been the target. But our hypothesis is that it's one of them. It's also possible that Spica, I mean, Beta Librae could have been the original target, and Spica, because it was so much brighter, was considered a proxy for Beta Librae. But we're not sure about these things. So the point here, all we would like to claim is that both these might fit our hypothesis. So what we will now do is, for these 2 stars, we will consider both of them. So for both of them, as I said, we can come up with these kinds of linear models. So we can calculate the angle as a linear function of the year, by simply interpolating with this data, fitting a linear regression. What happens is, of course, is that this is assuming that there is no error. We can precisely calculate the year because that's the data that we're particularly interested in. But of course, there is error. So if we introduce some sort of error term in the angle, then we will get a corresponding error term in the year. So let us examine the possible sources of error. And there are 5 that we can think of. We can group them into 2 groups. So errors that could have crept in when the temples were being constructed. Of course, we have assumed a method for actually measuring the angle. We don't know that, but whatever method there was surely some error in that method. And then, we have assumed a certain altitude. If the altitude was a little bit higher or a little bit lower when the error was, when the measurement was taken, that itself could have introduced an error. And of course, when the temple was actually constructed, I mean, if they would have laid out this orientation line, then the actual construction may not have aligned perfectly with that line. So each of these could have introduced some error.
Can I interrupt just now, very
yes,
briefly?
please.
You chose altitudes of 3 degree and 4 degree for the 2 candidate stars.
Yes, yes.
Is there a good motivation for why you choose those altitudes?
Yes. So let me just back up for this. So we know the angle range that we're interested in, and so we were able to see that for Spica at 3 degrees altitude and Beta Librae at 4 degrees altitude, we were getting this close fit to the angles that we were interested in, right? So basically, that's the reason. I mean, we actually only considered sort of integer altitudes. There's no good reason to do that, but these are sort of like 2 sparse data points that we considered, which fit the date range.
There could be another motivation, which is, are these altitudes good altitudes for making measurements at?
Yes. So this is a good question. So are these good altitudes for making a measurement at? So yes, if the altitude is too low, then there will be, the stars will not be visible enough. So we did consult a few people some of whom we will thank in our acknowledgement slide. So we did run these numbers by them. And so neither of us are professional astronomers, but we did find out from some of the people we consulted that these are acceptable altitudes at which to measure. Right? thank you for asking.
One more question,
Please.
which is in an early slide, maybe some half a dozen or a dozen slides earlier from Rajani.
Yes.
There was some difference in the angles between the Tibetan structure of the same date range as an Indian subcontinental structure. Something from 770 to 823 or some such numbers. So they were identical date range, but different orientation angles for the two structures. So is that in some way related then? Are you going to address that issue as well later?
Yes, we will take a look at that. So one of those things, it's a function, as I said, also of the latitude. I suspect that the answer to your question will be, but maybe we can hold that back and make sure we address that. Okay. So we can come back and relook at that slide.
Sure.
The difference. Yeah. Okay. So now for our methods, as I said, the errors because of our methods as well. So we have tried to measure as accurately as possible, but there could be errors over there, and of course there may be some errors introduced because of the stellarium models. So all these, of course, are unknown, we cannot quantify them. So the best we can do is talk about the cumulative effect and try and see if we make assumptions about what that cumulative effect is, how badly does it degrade the kinds of claims we can make. So we mentioned earlier, Rajani mentioned that there are these three, and I think this was also what you were asking about, how, so the question, Rajani, was that, there is the temple at Samye, which has a date range very close to some of the temples here, yet the angle is quite a bit different. So in fact, we will address one of the reasons for this, but as I said, part of the reason is also difference in latitude. But the major difference is what I'm just going to address over here, right? Did you want to also? One second.
The measurements for each of these sites were made at their latitude and longitude. I mean, we took their location into consideration. So for each site, measurements across the whole period was made.
Okay, so as I said, we have good dates for three of them, but unfortunately, we are for two of them, these angles are kind of high, which was, I think, the observation you were also making. And so our explanation for that is really this issue about occlusion, right? So each of these is about 1.4 degrees higher than expected, even, and with the Samye structure, even after, as Rajani was saying, accounting for the difference in latitude. So let's understand why that is, because we can at least give a unified explanation for why both these are high in terms of occlusions. So when we look at Vikramshila, this is what this is a false color image showing the heights. So these red regions are higher than the blue and the yellow and the orange regions. So this is the direction in which this star is rising, and you can see there is an occlusion, and you can also see the same sort of occlusion from the ground view. So you can see that there is some occlusion here. Now we must mention that there is a lot of activity here geologically. I mean, with the river around here, so we don't know for sure if this occlusion that we see here was exactly like it was at the time, and it could have been higher, it could have been lower, it could have been slightly different. So the point is that we do see some occlusion here today. So occlusions to the east could be one reason why the numbers we're seeing for Vikramshila are high. Now in Samye, it's interesting because here again, of course, this is in Tibet, so there are high mountains here. And if we look at the location where they finally did lay out this particular temple, and you look in this direction, which is the east, right? Or rather, this is the direction of the star rise. So left here is north. So this is roughly east. You notice that if they had placed this structure any further north, they would have had even greater occlusion from these faraway mountains. And had they placed the structure any way further south, they would have started getting occlusion from this nearby structure. So in some sense, they may have found the best compromise to look towards this direction with the least occlusion possible, to look in this direction. So the point still remains that even with Samir, there were occlusions here, and this is probably the biggest part of the answer to your question about why the numbers were slightly higher. So despite the fact that we do have good dates for Vikramshila and Samir, we actually can't use them for this reason, because we do have this concern about the occlusion. So we focus instead on Somapura, where again we have some evidence that it was built by Dharmapala, for whom we have dates. So we have this narrow range. Seals have been found to connect. There is no occlusion here for Somapura. So here we can go ahead. And here, this is also where we did a little bit of investigation about possible angles, possible altitudes, right? So we looked at, as I said, a few sparse data points, admittedly. So we tried 2 degrees altitude, 3 degrees altitude, 4 degrees altitude for Spica, and similarly for Beta Librae. And here we had to go slightly higher to make the dates work out. And over here, we have made some assumptions what the cumulative error was. And what we found is that if we have a reasonably small cumulative error, then 3 degrees seems to work well for Spica, and 4 degrees seems to work best for Beta Librae. So now, with that assumption that we are talking about 3 degrees at Spica, we can similarly do this calculation for Beta Librae, which we're not showing the data here, but it's a similar calculation. So we get these linear models. And as I said, the only difference between these is because there are small differences in latitude. The biggest difference is actually with Samir, which is way up in Tibet. So there the numbers are slightly different, but otherwise the linear models are very similar. And then with these linear models in hand, we can do what we really wanted to do, which is on the x-axis, we have plotted the cumulative error. And using the cumulative error, we can estimate the date range. So here we are hoping that we are making some novel predictions about these temples, about the date ranges, right? So of course, there are several assumptions baked in here. So if our hypothesis is correct, and stellarium is accurate, and we don't have too much error, then we can potentially make new claims about when these temples were constructed and their relative order, right? So this is sort of the kicker to the whole slide. So I'm going to hand over to Rajani we have one more. this was a late edition. So this was a late edition. We decided we wanted to show one more result. So we did this analysis. We presented a paper and we spoke about those temples. And there's one more structure. This is just north of Nalanda. Rajani mentioned Udantapuri. Right. And she also mentioned we don't know where Udantapuri is, but in another paper that she wrote, she identified this mound, which has a very seductive shape. In fact, she was giving a talk and someone said it looks like one of those fidget spinners. But a little bit more seriously, it looks like, in fact, very similar in its structure to Vikramshila and Somapura, which again were similar periods. So here are the outlines of those structures. And here is something we can do quite easily in the digital world. We can basically do a copy paste of these and put them in here, and they fit, right? And they fit. In fact, Somapura, which doesn't have the occlusion, is a far better fit to this overall shape. Now, we cannot make any very solid claims because we certainly don't have any walls whose orientation we can measure. But at least at this gross level, we can see that this four-sided structure, which is similar to these quadrangles here, is a good fit to Somapura. And again, if this really was Udantapuri, then here is some evidence in support of that, because the dates that we have, we can plug into our linear model for Nalanda. This is located virtually at the doorsteps of Nalanda. We can plug in the same linear model and we get almost the same angle that we get for Somapura. So the fact that Somapura...
Can I ask a question, please? This is...
Please. Yeah.
Is there a possibility of using radio frequency techniques to, without, breaking into the mound to get an idea of the structure?
Yeah, I can answer that. I don't have the surface images in this PPT, but I can share it sometime. This is a large mound. It is about nearly half a kilometer on east-west and little less on, I mean, it's about 400 and 450 meters across. And the north half of it is covered by a settlement. And so if I saw this mound with an image like I am using for Vikramshila and Somapura, I wouldn't have identified this shape because the shape is only in the height map. I have been to this site and there is a lot of modern construction, but there are also areas which are like this part, the northern wing of this, where when I went and visited this village and asked people around if there have been any exposed walls and so on, a farmer took me to his plot, which actually coincides with this location here, where when he was digging up his plot to replenish soil to improve fertility, they ran into some bricks and a stay order was brought, but nothing happened later. He started cultivating in that land. But it is a very neat structure inside in that trench. And I had the opportunity to collect some bricks that were thrown out from this one. And I did date them using AMS technique in IISc Delhi and got some very promising dates for that too. But there are patches of this area which can definitely, we can use GPR, but something that hasn't been done yet.
Thank you.
Yeah, so I now come to my acknowledgement slides. The beginning of this study itself has been very interesting. It started very unusually. Dr. John Marr, who's an Indologist, I was traveling with him in Madurai. This is Meenakshi Temple of Madurai. He was pointing to me these steps which sort of disappear into the sites because the orientation of the tank is tilted from the orientation of the larger temple. And he was trying to tell me that the orientation of tank probably dates from a different time from the orientation of the larger temple. And this should have some astronomical explanation, maybe connected to precession. But at that time, this was somewhere around 2003, 2004, and I didn't know what all this meant. But about nearly a decade later, I was talking to Professor Frederick Asher, who was writing this book at the time, Nalanda Situating the Great Monastery. And he had noticed that the Nalanda's sacred structures have something to say in their orientation. He asked me if he had tried to measure the orientation on the site and not been successful. So he asked whether I can measure it with satellite imagery. His assumption at that time was, can we group them into two? This is Pala period, and they did this way, and this is Gupta period, they did that way. So I offered to measure, and then I found I can't group them into two. They are all different, but they're showing some pattern. So that set me off on this journey of what we have presented today. So I thank both of them and their discussion that was a decade apart and sort of seemingly disconnected led to this study. I thank, of course, Stellarium. Without that, I couldn't have done this at all. And my colleague Sonia, who helped a lot in measuring this orientation repeatedly many times using AutoCAD. And Professor B.V. Srikantan, with whom I had been discussing this at every stage. Professor Mayank Vahia, with whom I have discussed many ideas with, about astronomical explanation and their connection with archaeology. And Professor N. Kumar, to whom we had presented the first early findings even before our ideas had properly crystallized, and Dr. Jayant Murthy from IIA Bangalore, with whom we have also been discussing at various stages, Dr. Shailaja from Nehru Planetarium, Bangalore, and Dr. Naval Gun, with who helped us a lot to understand the geomorphology of the area and how these changes, something that Viraj referred to about the river movements near Vikramshila, which could have caused the occlusion to be different from what it is now. So with that, thank you very much. And it has been a great pleasure to talk to you. we'll be happy.
Thank you very much to both of you for a wonderful lecture. I think I'm sure there are many more questions than what were already asked. So I now request the participants either in the Zoom to kind of raise their hand, or also in the YouTube if you would like to type in some questions to the speakers. Let me start by taking a couple of more questions from YouTube. One question is, how revolution of Earth around the sun affect these measurements of degrees with reference of stars?
Sorry, I didn't follow the question.
Okay, can you hear me now?
Yeah, I can hear you, but I couldn't follow the.
Okay. The question is from Ram Nandan Kumar. The question is, how revolution of Earth around the sun affect these measurements of degrees with reference of stars? I mean, this exactly, I was reading what was typed in.
Okay. The movement of stars change very slowly. That was the whole idea about this precession. The stars, the rising of stars change by about, let's say, 1 degree in 70 odd years. So it is not really connected to the revolution of Earth around sun, but it is connected to the precession. That is the point in the cosmos that the Earth's axis is pointing. It's not really connected to Earth's revolution around the sun.
Okay. There's a question from Alakre. Why did you identify with Udantapuri? Or how did you identify? I didn't get this question. Okay. Sorry, there is a, okay. Did you read the, okay, this is a different question, but maybe Alak can clarify a little bit, but if you...
Why did you identify it with Udantapuri? I understand his question.
Okay.
When I was doing my literature review for Nalanda, Nalanda's location and what are other sites there are, this of course goes back to another paper and another research, connected research, which I did earlier, where I was looking for archaeological mounds in the surrounding of Nalanda, and I found that mound, which was our last slide, showing that so squarish mound. So when I first thought of publishing it, I just thought of saying, oh, this is an archaeological mound because it has this anthropocean shape. The reviewers said that it's not enough to just put up material saying that this is archaeological. You should hypothesize what it is. Hypothesize whether it should be similar to some other known site, and therefore it should be the time of this and so on. So that led me to look deeply into what were the contemporary sites sites of Nalanda, which fitted this shape, size, and orientation of this mound. So I found Vikramshila, I found Somapura. And when I was looking up Vikramshila and Somapura, I found the that they were built by Dharmapala. And while reading about Dharmapala, I found that he was the second or the third king of Pala dynasty, and the first king, who was Gopala, built Udantapuri, and we don't know its location. So it was because then I started looking at what do we know about Udantapuri's location, and I found that the evidence that is for the Udantapuri location, which is believed to be Bihar Sharif, is very weak. And here I have a geographical evidence of size, shape, and all that. So I made a suggestion whether this could be the site of Udantapuri, because it is in close proximity, and also there's literary evidence that people are walking across between Nalanda and Udantapuri, and that was my reason.
Okay, we'll come back to the questions, but there's one more, I think, follow-up from Alak. Did you read the novel by Biman Nath of RRI, Nothing is Blue, which is about precision and Nalanda times?
I see. No, I haven't read it. I will look it up. Thank you.
Okay. I mean, he's still typing some more questions, but I would like to come back to Zoom and take a couple of them. First, Datar, do you have a question?
Yeah. Yes. My question relates to has radiocarbon dating been done on the sites that you looked at, the temples 2 and 12 and so on? And does that corroborate with what you find on the basis of star positions?
There is a problem in doing radiocarbon dating on material from any of these structures. I tried to explain earlier on, because these structures have been heavily conserved by or renovated by putting newer bricks and newer mortar. And so recognizing an old material is a issue in this protected area. Of course, we can't pick up anything from a protected area anyway. But even if we were able to, recognizing authentic old material from these sites is an issue.
Thank you.
But I have identified several mounds in the outside this protected area and collected bricks, which are sort of semi-baked bricks, and we have tried to date them, and they fall in the range. But these are not the sites for whom we have measured orientation, because they are unexplored, unexcavated. So it is possible to do dating, AMS dating on this material, only if we are sure of identifying an authentic old material from these structures.
Okay, another question from Krishnan.
Yeah, I actually have a couple of questions. Okay. One is I want to revisit this issue of the altitude of 3 or 4 degrees. That still looks very low to me. And so it seems very, very suboptimal if you actually want to use it to orient a place, basically because there's so much of muck in the sky at such low altitudes that you would do much better if you were actually aiming. Let me ask the second question as well, and then maybe you can address both things. Okay, so the other thing was with regard to the error bars on your kind of stated orientations based on satellite imagery. I noticed that you were specifying good to 0.01 degree. So you said you had 2 baselines and you took an average of those 2 baselines to find out a number. Each individual, I also noticed in one of the slides that there were a whole lot of yellow dots, which were kind of tracing out a line in some sense. So what are these yellow dots, and what was your basic error on the measurement of any one single line?
Yeah, 1 second. Sure. I'm just going back.
We'll just pull the slide up, and I think we're on the slide. Go back. So we get to the question. Here we go. I think that if I understand correctly, Krishnan, your question about the yellow dots was on this slide.
Can't see the slides.
Yeah, you have to project.
Share the screen.
Yeah.
Sorry. Okay, sorry, just a second. We'll just share. Yeah, just a second. Sorry. Where are here we go. So, share that. Is this the slide that you were talking about?
No, not this. The yellow dots were actually on the structure.
Yeah, this is the other one. I know which slide he means.
This one?
Yeah, this one.
Yes, this is it.
Yeah. So here, this is what we were saying. We were trying to. So this is the central structure, which we believe was the one that was carefully oriented. And if we were trying to measure its angle, we said, well, the best approximation to that is to measure the angle of this northern straddling line and the southern straddling line, and take the average of those two. So this is the best line that we could draw. That is.
What are the yellow dots here?
Yeah, it's just marking the wall that we measured. But of course, when we measured, we didn't use such a thick yellow dotted line. It is only to make it visible on this PPT. We use this, but it is just marking the wall that we measured.
So it's just a guide to the eye on this slide. That's essentially what it is.
Right.
Okay.
Right.
Yes.
But then so come back to the basic question, how accurately would you place the orientation of the line itself? What is your best estimate of the measurement? If you had 2 independent people doing the same line, how much would they differ by?
Yeah. No, I think the question is, is it even fair to start looking at errors of as small as 0.01 on this graph that we later on had, right? And yes, I mean, definitely at the low end of these things, I mean, these are unrealistically low errors. So I would estimate that, so we did ask our colleague Sonia to measure these multiple times, and this is an off the cuff recollection. I don't recall two of her errors being off by more than a tenth of a degree. She was measuring them to she was using them to the nearest four decimal degrees based on her on the AutoCAD, but no two of her measurements of the same line were off by, if I remember correctly, less than half a tenth of a degree. So just that part of the error, which is only one part of this cumulative error, of course, we feel is more in this range, 0.05 to at most 0.1.
Yeah, and also we found the two straddling lines were about 0.2 maximum difference. Maximum difference was 0.2 between them.
Between the northern and the southern line for every structure. And in many of the structures, it was less.
Yeah.
Okay. Now coming back to the altitude question, 3 degree, 4 degree.
Yeah.
Okay. We considered, of course, based on what is the extinction of each of the stars. I think one of our early slides give the extinction of Spica. I mean, when we talk about those 4 stars, give the extinction values. Yeah. The earlier one, I give the extinction value of all the 4 stars we consider. Yeah. So do I give? No, I don't give. Yeah. So we did consider, since we consider only Spica and Beta Librae, we looked at what is their extinction values at 3 degrees. And Spica, whose magnitude is 0.95, its extinction is about 2.4 or so at 3 degrees. Of course, Beta Librae, whose magnitude is 2.6, its extinction value is 4 point something. So it obviously is much more dimmer. So we consulted, Professor N. Kumar and others on this. And since the extinction value, especially of Spica, was not too bad at 3 degree, we took that. Of course, if it was any larger, it wouldn't fit into our,
Okay, thank you.
Thank you. Any other questions? Can we stop sharing this?
Satya, you have to come back.
I was in mute, so I should just give me a second. Yeah, I was saying that a question from YouTube from Upasana, I think you have just answered it, but nevertheless, let me read. Was Nalanda aligned to Spica just because it is one of the brightest star and located near the intersection of ecliptic and celestial equator? Or is it Spica has some other historical importance like Vishaka?
I feel between the two, Beta Librae and Spica, I'm of course partial to Spica for many reasons, because it is a brighter star and astronomically important and all that. But we have no evidence of whether it had any other historically important reason. We don't know whether the builders of Nalanda or the people who decided on aligning, if they decided aligning with Spica, knew that Spica would give them data about axial precession. We don't know. So we don't have any evidence. I mean, I have tried to look at as many astronomical treatises there are at the time, and all the mentions of Spica. So we can't say any more than that.
Another question from Malak. What was the result of your analysis of bricks from radioactive dating?
So we, as I mentioned, we didn't date any structure from the protected area, from any structure that I showed pictures of, because they are renovated structures and we can't collect material from them. But an earlier work of mine which studied the vicinity of Nalanda, I had identified many archaeological mounds which we visited, and we found lots of old bricks just sort of sticking out from those mounds, or pulled out while plowing, and they used it for sort of weight on dry grass and things like that, which is very visibly old. So we collected some such and we dated them. We got some dates for some mounds that fall within these range of when Nalanda was active. Some dates we got earlier than that, of course. But having said that, we are able to attribute those dates to the mounds, not to any structure, because the structure in the mound is not exposed yet.
So that is just a follow-up question that I want to ask, which was also asked by Mr. Vivek Datar earlier. So are there some thinking in the Indian space where techniques like what I think I'm not sure if they are well established or infancy, using cosmic ray muons and other radiations for actually studying the structure of hidden structures, basically what is beneath and inside. Are there some initial trials or some kind of attempts happening on that?
So, the main method to see buried structures are GPR, which haven't been still used for this site. There have been other archaeological sites, especially Professor Javed Malik from IIT Kanpur has done many other sites. There are complications in this site and its surrounding because there are many villages that have cropped up on large archaeological mounds. In fact, there are written evidence, written records from 19th century. The first archaeological surveyor of India, Cunningham, and earlier to him, Buchanan, who, when they visited, they saw people taking away bricks from the site to build their own homes, because this large archaeological expanse was free source of building materials. And the observation they had from many other sites, including Nalanda, was one of the reasons which later led to the Archaeological Monuments Act for stopping people from doing this, which was in 1904. So
I think there's clearly opportunity to explore.
But there are a lot of surface complications. There are certain patches which we can use to do subsurface sensing, but quite a lot of them is either built over with villages or cultivated. So there are such complications in this site, I'm sure, as many others.
Okay, there are again a couple of more questions come up on the Zoom. First is by Sushil Majumdar.
Yeah, hi. Thanks for a very fascinating presentation here. I note that in your analysis, the date of the structure is a very important input. So I was wondering if inverted techniques can be invented, similar to yours, but inverted, such that you can actually infer about the date of an ancient structure from the analysis?
Yeah, so that is what we tried to do. I mean, eventually we only had one good date to seed this whole effort, and that was for Sompura. For all the others, the whole idea was really to try and infer the dates, as you were saying. So we can see the orientation of the structure. I mean, we can try and measure it as accurately as we can. We couple that with the hypothesis that it was oriented to the rise of Spica. Then using astronomical models, we have dates, right? So that is what we have tried to do. And here we didn't have to do anything very complicated because, as I said, a linear model in that particular date range was good enough. So we just a simple calculation. Maybe I didn't quite follow your question, but that is exactly what we were trying to do, to infer dates based on orientation.
For the ones we don't have dates from other things. I just want to add here, orientation actually marks the beginning of construction. So it is quite possible the orientation was done and some amount of foundation was laid, but the superstructure didn't get constructed for decades after that. So that kind of thing is also a possibility. But what we're dating is the orientation rather than the actual construction.
Right. Thank you.
Lower bound of the date.
We have 2 more questions. I guess we will end with that. I'll take in that order. First is again Professor Vivek Datar.
My question relates to the possibility of finding dates for other universities like Takshashila or maybe Mithila University, which are also quite old universities, supposedly.
Yes, this of course opens up possibilities for dating many structures. In fact, when we did this work, we did a survey of all possible sites that had some sort of connection, belong to the same socio-cultural milieu of Nalanda. So, and saw what structures were available. Most of them had structures of round shape, which are stupas, which are the main architectural type of Buddhist sites. Probably they also had some orientation when they were laid out, but their current structure or the superstructure doesn't reveal it to us. So that becomes difficult to measure. But even within the sites we have seen, we haven't really given dates. For instance, that one Temple 3, the first structure I spoke about, which had multiple faces. So if we are able to identify more lines belonging to the same face, we may be able to give dates for those also. So the possibilities are many. I have subsequent to this work, identified in my work, identified some structures in Sarnath, which also could be considered. The layout of Sarnath itself also has that similar tilt. But again, getting a very neat, narrow line is a challenge in those. But
at one point, the method that we have followed is looking at the satellite point. If there was a ground-based method for getting the orientation, the hypothesis could still be tested.
Thank you.
So before we take really the last question from Krishnan, as you are talking about other possible universities or sites, there is also a question about Brodeswara temple in South India. So what about the orientation of South Indian temple, especially
the simple answer is orientation as a topic itself is not researched very much, other than, yes, there is a lot of work on looking at orienting structures to the sun, because sun is obviously the most bright body in the sky, and there are many structures from many civilizations, and in fact many people I spoke to first, they said it has to be sun, why will people look at anything else, kind of reactions. So orienting structures to stars is not a thing that has been explored with Indian structures. Yes, I mean, I'm looking forward to, as I acknowledged Dr. Mar telling me about orientation of Madurai temple and its tank. It is something that I haven't looked at yet, but it is definitely a very potential area for this.
Okay. That really.
We're always looking for good PhD students.
It's always the.
Aren't we all?
Right? Yeah. It's a last question by Krishnan.
Yeah. So, it's interesting that there should be so many structures within fairly narrow geographical confines in this one location, which differ in angle. Now, when people get down to constructing structures, they might also take references from already existing structures. And certainly, constructional practices in the ancient Indian world were accurate to tens of arc minutes. I mean, you can, for example, go and look at the sculpting of the Kailash temple in Ellora, and you will find structures over there, pillars, for example, which are misoriented from each other by much less than a degree. So I'm just wondering why on each occasion would people want to relocate spica rather than derive reference from an older structure, that older, man-made structure already existing in that site? Is it that lines of sight were not available from one temple to the next, so that they could, pick up a reference from one and transfer it to the next? That's it. That's my question.
Okay, actually, this whole research started only because, for instance, if we had found that there are 5 sites in 5 different locations, which has similar orientation, we would have put it down to if the latitude is different, or the location is different, and therefore it is different. The whole idea of this curiosity began because it was in one place that we found 5 different angles. And why is that 5 different angles? So what we think is that spica, I think it is spica, it may be beta librae, but I think it is spica. The importance of spica as an astronomically important star also was established, and people were building, aligning with that. It was not, and these structures were built decades or centuries apart, because the site was active for 800 years or more. So they were not just built, and there was some competition as well between because each one was patronized by different kings, and there was some competition as well to build something better or bigger, different and things like that. So they were not built at the same time. Obviously, that's why we are here. So the whole idea of, yes, it was, there is something that the orientation is telling, was because they were all together and they were all slightly different.
Okay, so I guess now it's time to thank you. It was a wonderful talk. I mean, it has also induced a large amount of discussion and curiosity among the participants. And we also, of course, wish you great with your forthcoming book next year. And so before we say bye, but I'm sorry, I forgot to acknowledge Professor Vinod Prabhakaran,
Thank you, Vinod.
who actually was instrumental, who actually proposed this talk. And of course, I did kind of place it in the chat window, but I want to also personally acknowledge him. And it was really, really a wonderful talk. Thank you very much, both of you. And I wish you all the best.
Thank you very much for the opportunity, and thank you very much for all the questions.
Thanks.
I really enjoyed talking to you.
Thank you.
Thank you. Bye-bye. Take care.